Okay, so we have physics periodic on Tuesday. Today it is Friday, January 12th. Periodics on Tuesday we have 2.10 to 2.14 and 3.1 to 3.16. Uh, More than half of the material was in the final. In the final we had 2.10 to 2.14 and we had 3.1 to 3.7. So the only new stuff is going to be 3.8 to 3.16. Which isn't that hard, by the way. It's what came most of it in the AMS on Thursday, which I think most of you guys did good in. That's in our school, يعني in Sharjah, we did good. Uh, مهم, this is the 2.10 to 2.11 quiz. This is 2.10 to 2.11. The recording will have from 2.10 to 2.14. خلاص enough yap. Let me start. A particle initially at a point with coordinate x equals -2 is moving towards the origin at a constant speed of 5. Okay, before we continue, I'm going to write down all the formulas. 1 second. Okay, so I wrote down these are the URM and UARM formulas, just in case you forgot them. First, we have Vt plus x equals Vt plus x naught. This is URM. X is displacement, V velocity, T time. X, this is x0, x node, whatever you want to call it. Some people put xi, which is the initial position or the initial displacement. UARM, you have V equals AT plus U. You have X equals half AT squared plus UT plus X node. You have V squared minus U squared equals 2AX. It's the same letters. It's just that U is the initial velocity or the initial speed, whatever you want to call it. You can take a screenshot of it if you want to zoom in. Let me. If you want to take a screenshot of these, take a screenshot. But yeah, these are the formulas. Everybody knows them. I think you guys remember them. Let's just start solving. The first thing is the particle is initially at a point with coordinate x equals -2. Yeah, and it's moving at a constant speed. Of 5 meters per second, moving towards the origin. If it's at a -2, moving towards the origin, oh, that means it's going in the positive direction, okay? So it's a positive velocity. Just a note. Okay, in 10 seconds, the position of the particle will be, because, okay, since it's constant speed, okay, constant speed means URM, okay? Just remember that. So whenever you see constant speed, always think about x equals Vt plus x naught. X equals velocity is 5 times 10 seconds, and x naught, the initial position, is -2. You get 50 minus 2, which is 48. Okay, a boy is initially at a point with coordinate x12, so he's at 12, and he's moving towards the origin. So obviously, if he's going towards the origin 0, he's going the negative direction now. He's moving towards the left at a speed of 4. So since we're going to the negative direction, our velocity will be -4, not 4. Okay. In 10 seconds, position of the boy, same formula. Since it's a constant speed, we're talking about URM. As that's not an, that's an M. So you do x equals Vt plus x node plus x node. X equals velocity -4 times the time 10 plus 12. So -40 plus 12 equals -28. Okay, this one, a particle at the origin starts from rest. So starts from rest means the initial velocity is 0, so u equals 0, and it accelerates at 2 meters per second squared. So they give you the acceleration equals 2. They say the particle will be 81 meters away at how many seconds? So they gave you x equals 81, and they want the time, t. Okay, they want the t. Which formula? Yeah, for me they gave you displacement x. They want you the time. For the formula that has x, a, t, and u is x equals half at squared plus ut plus x naught. Okay, that's the formula. X equals half at squared plus ut plus x naught. Okay, so since u is 0, you can cancel out this ut, And since it starts at the origin, so x node is 0. Origin means you're starting at 0, so the initial position is 0, so you can also cancel this out. So you're going to only be left with half at squared, in this case only. Our acceleration is 2, and our time squared, we don't know, so we just leave it as time squared. 2 cancels with 2, you'll be left with x equals time squared. The x they gave us was 81, so 81 equals time squared. So time equals plus minus radical 81. So you'll get 9 and negative 9. Okay, but you guys know time can never be negative, so it's just 9. Okay, it's 9. Okay, this question is a bit tricky. An athlete starting from rest. So starting from rest, yani velocity, the initial velocity u, u equals 0, and obviously x node equals 0. Okay, since you're starting from the rest and you start from the start of the racetrack, he's running 150 meters of a race. The first 18 meters has a constant acceleration, so UARM, 3 seconds. So 18 meters in 3 seconds. The athlete runs the remaining 132 meters with the same velocity he had by the third second. Okay, they're asking what's the acceleration in the first 3 seconds. So first 3 seconds, that means we want to focus on this sentence over here, okay? This is what matters to us. We don't care about the rest of the question. The, the first 3 seconds, 18 meters is your displacement, and the time is 3, and they want the acceleration. Okay, usually to find acceleration, you're usually going to use the velocity, okay? But in this case, we don't have the velocity. If you ever want to find the acceleration without any velocity, you do x equals half at squared plus ut plus x naught. This formula gets you the acceleration without the velocity, okay? So ut will obviously be cancelled out because we started from rest, so u is 0, because you know we're cancelling out since 0 times anything gets cancelled. And x naught is also 0 because we started from rest. So x equals half at squared. X is 18 meters. Half acceleration, we don't know it, and time squared will be 3 squared. Okay, so it's going to be 18 equals half 9 times a. So 9 divided by 2 is 4.5 a. You take 4.5 to the other side, it'll be 18 divided by 4.5, which is 4. Okay, over here. Part B is easy. They're saying what's the velocity at the end of the first 3 seconds. Okay, velocity equals acceleration times time, plus u, of course. But in this case, u is cancelled because we started from rest. So v equals acceleration, since we know the acceleration was 4 now, times the time, which was 3 seconds. Okay, it equals 12. 4 times 3 is 12. For part C, the total time it takes the athlete to run the full 150 meters. نحن we already run 18 meters and it took us 3 seconds. فبقي لنا we have to find the time for 132 meters. نحن بنعرف انه velocity equals displacement divided by the time. Okay. والvelocity for the remaining, he's running at 12 meters per second, فبنقول 12 equals, and the displacement is 132 meters divided by time. فنحن بدنا نعرف التايم. فهي time is 132 divided by 12, and you get 11. You get times 11. فهيدي for the 132 meters. With the first 18 meters كانوا 3 seconds. For 3 seconds plus 11 seconds هي بتطلع 14 seconds because we want the full 150 meters. Okay, constant velocity, constant non-zero acceleration. Okay, a jogger continuing to run at a speed of 2 meters. Okay, he's not changing his velocity, so it's constant. A hammer falling near the surface of the moon. Obviously, if the hammer is falling, it's gonna be falling and like it's gonna be accelerating as it falls. It's non-zero acceleration. The cart moving in a straight line, it's gaining 5 each second, so it's accelerating. Okay, a box steadily sliding down an inclined plane. If they mention the speed, then it's a constant velocity. Okay. Okay. The car it starts at 3. Okay. So x naught is 3. It's moving negative direction at a constant speed of 0.4. The speed is negative 0.4. velocity is negative 0.4. They want the position at 2 seconds. Since it's a constant speed يعني URM, فيو use x equals vt plus x node. Okay, x equals v velocity is negative 0.4 times the time, which is 3. Sorry, no, my fault. Times the time, which is 2, plus 3, which is x equals negative 0.8 plus negative 0.8 plus 3, which is 2.2. هي مظبوطة. Okay, a toy car is initially moving at 2.5, so the initial velocity is 2.5. It starts decelerating at 0.2, so the acceleration is negative 0.2. They want the velocity after 2 seconds. So since it's accelerating constantly, it's UARM. Okay, and they want the velocity. You have U, you have A, and you have T. So it's V equals AT plus U. Velocity equals acceleration, which is negative 0.2, since it's decelerating, yeah, times the time, which is 2, plus U, which is initial velocity, which is 2.5. So you get 2.1. Okay, now we're at the 2.12 to 2.14 quiz. Okay, there's a lot of questions in this quiz which are complete bullshit, and like they're just long. I didn't bother doing them, I think. Yeah, these ones I skipped. I just didn't do them. Just they were pointless. Starting off with the backpack question, I remember this question from term 1. This is not coming. I'm telling you from now. It's like the questions. It's طويل على الفاضي. These ones will come. These they come every time. They're in the MS quizzes. Hey, this is gonna come. This one also. Let's repeat this one. This one كمان it will come. هيدي C it will come. بس أنا calculated it wrong, so I got it wrong. I'm not saying C will come. بس يعني I'm not saying question 8 will come. قصدي question 7. I'm not saying it's gonna come. بس يعني I'll explain it. Okay. This one won't come. The question is wrong أصلا. Okay. Why? Okay, I skipped question 9. 10. And where's the elevator question? Hold up. I can't find the elevator question. Okay, this one, it was in the MS code. It'll probably come. Okay, yeah. فمهم I'm gonna solve these ones I skipped. It's because they won't come. Okay, I doubt they'll come. Yeah, they won't come. I'm not even saying I'm gonna doubt. I'm telling you they won't come. They're too long. وكلهم على الفاضي. They won't get these types of questions in the exam. Okay, I think صراحة the exams they're gonna bring mostly forces. بحس انه هيجيبوا هو multiple choice questions تبع forces. ف we see. بس هيك I'll solve these. This one I told you I won't solve. بس المهم we'll start here. A cyclist passes the start line with a speed of 2.8. So he passes the start line with speed of 2.8. So he started with 2.8. So the initial velocity is 2.8. Constant velocity, positive direction, constant acceleration of 0.2. So acceleration is 0.2. We want a displacement. Okay, displacement. They give us a time. Displacement when you don't have velocity is x equals half at squared plus ut plus x node. Okay, so x equals half acceleration, which is 0.2 times time squared, so 20 squared, plus ut, so 2.8 times 20, plus x node, which is 0 because it's a start line. You equate all of this, and I'm pretty sure you'll get, yeah, you should get 96. Let me put it on a calculator. 1 over 2, 0.5 times 0.2 times 400 plus 2.8 times 20 plus, yeah, that's it, 96. Oh, well, okay, المهم it's 96. It's 96. Now a cyclist accelerates from rest. So from rest, so u equals 0 for 20 seconds. So times 20 at a rate of 0.5. So acceleration is 0.4. Sorry, 0.4 and 0.5. And then she travels the constant speed for 60 seconds. Okay, well, top speed of the cyclist during the motion is how much meters per second. Okay, you have they want velocity. the speed, they want the speed, which is the velocity. They gave you acceleration, they gave you time, and they gave you. So v equals at plus u. Okay, so velocity equals acceleration, which is 0.4 times the time, which is 20, plus u, which is 0. 0.4 times 20 is yeah, 8. Yeah. Okay. The net displacement of the cyclist. Okay, this part B, it won't come. But just to show you how to do it, it's like this. Okay, you have to draw a graph. Okay, VT graph. Okay, this is how to solve, like, just in case it comes, but it won't come. It goes up for 20 seconds until it reaches 8. Okay, and then continues for 60 more seconds. So it reaches 80. So 60 more seconds, so until 80, because 20 plus 60. You don't have to know this, that was going to come. But it's a trapezoid, so you find the area of the trapezoid is going to be 80 plus 60 over 2 times 8, and you should get 560. Okay, this is just the solution if you want. I thought it would come. This one, question 4. A particle moves with a constant acceleration, so a equals 8. Initial velocity is 4, so u equals 4. The speed after 3 seconds, velocity equals acceleration times time plus initial velocity. So acceleration is 8 times the time, which is 3 given in here. Okay, plus u, which is 4. 8 times 3 is 24 plus 4, 28. The displacement of the particle from the initial position just after 3 seconds is 48 meters. How do I do this? You do x equals half at squared plus ut plus x naught. فit's gonna be x equals half acceleration, which is 8, times the time squared, يعني 3 squared, plus ut, so 4 times 3, plus 0 because x naught is 0. Okay, this equals 48. Okay. Okay, a cyclist accelerates from rest for 20 seconds at a rate of 0.4. So times 20, a equals 0.4. Travels at a constant speed for 60 seconds. Travels at a constant speed. Yeah, and then after that, she travels at a constant speed for 60 seconds. So first, 20 seconds accelerates for 20 seconds at a rate of 0.4, and then after that, after she reaches that top speed, she travels at that constant speed for 60 more seconds. I think we solved this. No, question 3. Yeah, okay, my fault. Yeah, we solved this. We skip it. A man is standing on a rooftop of a building of height 85. He tosses a ball vertically upward with an initial velocity of 15 meters per second. Okay, I don't think this one will come, but I'm still gonna solve it because it wasn't the AMS quizzes. So a man is standing on a rooftop, and I already read all of this. And by the way, when they say g, they're talking about acceleration is negative 10, because g is gravitational acceleration. That's the acceleration that pulls the object towards the ground. Okay, so obviously if you're falling towards the ground, so that's going to be negative. As in terms of height, you're going to be going down, so that's negative. Okay, so the g acceleration in this case is negative 10. Okay, so the way you solve this is, let's say this is a building, is the windows, whatever. The man is standing up here, right? Okay, he throws the ball up until, let's say, a maximum height. Okay, ما بنعرف a maximum height. Okay, so let's say the ball reached here. Okay, they want the maximum height, so the height at this instant. And I want to tell you something. I think we're taking it in physics now. Okay, whenever you throw something, anything, whenever you throw something, it's gonna reach a maximum height. Okay, let's say this is 70 meters. At that maximum height, the velocity of that object reaches 0. Okay, so it stops moving for like half, like not even half, like a 0. Like 10 milliseconds. It stops moving for 10 milliseconds. It just freezes in the air. حتى when you, like, مثلا when you're on a trampoline, uh, this is a trampoline, I guess. When you're jumping, you stop in the air for like a fraction of a second. So when you reach your maximum height, the velocity is 0. Why I'm saying this is, I know when I want to do how high does the ball travel, usually to find the x, we were using x equals half at squared plus ut plus x naught. But in this case, we don't have time, so we're going to use v squared minus u squared equals 2ax. Okay, v squared, since at the maximum height velocity is 0, we're gonna cancel velocity squared. U squared, they said the initial velocity was 15 meters per second. Okay, so minus 15 squared equals 2 times acceleration. What's my acceleration? Negative 10. Negative 10 times x, which we're trying to find. So simplify it, you get x equals 50, negative 15 squared is going to be negative 225 divided by 2 times negative 10 is negative 20. You get 11.25. They want you to round it to get 11.3. For part B, the ball falls down to the ground. How much does it spend in the air? How much time? They want the time. The height is 85. So this is our x node because it's starting up at 85. So this is where the ball is being thrown. So it's starting at up at positive 85. It has a ball vertical initial velocity is 15 equals 15. A equals negative 10. They want the time. Okay, which one has x, a, u, and t? X equals half at squared plus ut plus x naught. So x equals half negative 10 times time squared plus ut, so 15t, plus x naught plus 85, because we're starting up at 85 meters. The building is at 85, so our starting position, our initial position is at 85 meters. Okay, so half negative 10 times t squared plus 15t plus 85 equals 0. Why 0? Because it fell down to the ground. خلاص, it's at 0 meters now. Okay, once it falls down to the ground, it's at 0 meters. Simplify it, you'll get half times negative 10 is negative 5t squared plus 15t plus 85 equals 0. Okay, now you want to factor negative 5 out. It becomes t squared plus minus 3t minus 17 equals 0. Now you can either solve this on a calculator, or some calculators don't have it, so you have to use the quadratic formula. Minus b plus minus radical b squared minus 4ac over 2a. Okay, we took this in algebra, by the way. Okay, minus b will be positive 3. Yeah, it'll be minus 3, so positive 3 plus. We're not going to take the negative solution because obviously time cannot be negative. So plus radical b squared, so 9 minus 4 times ac, so negative 17 over 2a, so 2 times a, which is 1, so 2 times 1 is 2. So let's clean this up a bit. It's going to be 3 plus radical minus 4 times minus 17 is going to be 28, 68. So 9 plus 68 over 2. Yeah, you're going to get 9 plus 68 is going to be 77. So 3 plus radical 77 over 2. After you do this, you're going to get something around 5.89, which is the answer. And I don't have my calculator beside me, so I won't be able to do it. This is 5.89. That's how you do it. It's a bit complicated. But I doubt it will come. But I thought I'd let you know. Okay, two athletes A and B are running on a racetrack. Okay, at time equals t1, athlete B is running at a constant speed. Okay, forget about this time equals t1. Athlete B is running at a constant speed of 6 meters per second, so it's URM. And this guy, athlete B, is in front of athlete A by 1 second. Okay, athlete B has 10 meters more until he reaches the finish line. Athlete A is running at a constant speed in the same direction as athlete B. So imagine two guys on a racetrack. There's two. Athlete A is running at a constant speed, but athlete B is running also at a constant speed, which is 6 meters per second, but he's in front of athlete A by 1 second. How do you find the distance separating athlete B from athlete A? Type, since it's URM, the formula is x equals vt plus x naught. The velocity of athlete B is 6 meters, 6 meters per second, and the time is 1 second. And x naught, we don't really care about x naught here. So 6 times 1, it's x naught is going to be 0 because it's between A and B. But if we're talking about the racetrack, that would be something else. Okay, since it's only between the two athletes, x naught, we don't really care. Okay, so you're going to get 6 meters. So between A and B, there's 6 meters. Then the time needed for athlete B to reach the finish line to 1 decimal place. Since we already have the distance, athlete B has 10 meters more. And we have the velocity, which is 6. We know velocity equals displacement divided by time. Okay, so velocity, which is 6, equals the displacement, which is 10, divided by the time, which we don't know, we're trying to find. So obviously the time will be 10 divided by 6, which is around 1.7. I think it's 1.67. It's 1.67, I think. But you round it to one decimal place, it's 1.7. I chose 10 because he has 10 meters more until he reaches the finish line. Okay, now they're looking at athlete A. They're saying what speed should athlete A run if he should catch up with athlete B. Okay, use your answer to one decimal place. One, athlete A and athlete B have 6 meters in between them, and athlete B and the finish line, let's put the finish line, has 10 meters between them. We want athlete A to reach the finish line at the same time as athlete B. So what speed should he run? Obviously, he should speed up, yeah. In between athlete A and the finish line for 16 meters. Okay, so we know velocity is displacement over time. To find this to find the velocity, we got to displace 16. How do we need to know the time? Okay, we want to A and B to reach at the same time. And since B is gonna reach in 1.7 seconds, after 1.7 seconds, we're gonna use our time as 1.7. Okay, so B after 1.7 seconds, B is gonna reach, but we want A to reach at that same time. So obviously we're gonna use 1.7 seconds also as our time. If you divide these, you get, if I'm not wrong, you get 9.4. Okay, but the answer is 9.6. It's because in the question they used 16 divided by 1.67, because the answer here we got, it was 1.67 here, but we rounded it. The question's wrong. 9.4 should also be accepted. Okay. Okay. I skipped 8 and 9 because 8 is wrong and 9 is one of the long ones. Okay. A cyclist on his bike accelerates from rest and he reaches the speed of 6 meters per second in 25 seconds. Okay. How do you find acceleration? You guys know acceleration is velocity divided by time. For 6 divided by 25, which is 0.24. Okay. Then he applies the brakes and then he comes to rest after moving through 20 meters. He was accelerating, he reached 6 meters per second. Okay, then he applied the brakes and he started slowing down through 20 meters. Okay, so he went from 6 meters per second to 0 meters per second. Okay, the acceleration of the bike after applying the brakes is how many meters per second squared? Now we want the acceleration, but we don't have the time. Okay, we don't have the time. The formula you need to use is gonna be v squared minus u squared equals 2ax. Okay, the velocity squared is going to be 0 squared. Why am I saying 0 squared? Because we applied the brakes, so it came to rest. خلاص, it became velocity equals 0. It stopped. Okay, but the initial velocity is going to be 6 squared. 6, يعني. It was 6. Why? Because we're only looking at that segment of motion from where it started slowing down. So the initial velocity over here was 6. It slowed down to 0. Okay, so we're going to put minus 6 squared equals 2 times the acceleration, which we don't know, times x, which is 20 meters. Okay, given. Clean it up a bit, minus 6 squared, so minus 36, equals 2a times 20. It will become minus 36, equals 2 times 20 is 40a. So a equals minus 36 over 40, which is negative 0.9. Okay, a particle initially moving at 12 meters per second is decelerating at 3 meters per second squared. They want the displacement. Okay, we don't have the time, so we have to use v squared minus u squared equals 2ax. Okay, velocity squared, since it came to rest, so it stopped moving, so 0 squared minus u squared, the initial velocity was 12 squared, equals 2 times acceleration, which is negative 3 since we're decelerating. Okay, وx هي we're trying to find it. For 0 squared minus 12 squared minus 12 squared minus 144 equals negative 6 times x. X equals 24 once you divide. Okay, the time it takes to come to rest is how many seconds? Okay, for part B, they want the time. We have the initial velocity, we have u equals 12, and we have the acceleration is negative 3. The time to come to rest, since we have the displacement is 24, the displacement doesn't really matter, but we know velocity equals acceleration times time plus u. Okay, uh, velocity is 0 since we're at rest. Acceleration is -3 times the time plus u, which is plus 12 because the initial velocity was 12. Okay, you take 12 to the other side, becomes -3t equals -12, and you get t equals 4. Yeah, that's how. Yeah, but this was the last question that I think is gonna come from this quiz. هلا I'll record the rest. I won't record all today because it's Friday and I'm not in the mood. Maybe I'll record 3.1, 3.7 because that one's easy. But yeah, that's it for this one. خلاص, chapter 2, we keep on repeating them. I don't think we're gonna see them after this periodic. Uh, thank you, I guess, for watching.